Capacitive voltage transformers. Voltage transformers are composed of a core, two windings, and insulation. VTs convert the high voltage of primary side to low voltage on the secondary winding with the turn ratio written on their plate. Because of the internal casualties, such as copper and iron casualties, the vector of the secondary voltage is different from the primary voltage. Moreover, the connected burden is capable of affecting the turn ratio error and phase displacement. If the actual amplitude of the secondary voltage is lower than nominal secondary voltage, the amplitude error is negative. Also, if the secondary vector is lagging in relation to the primary vector, the phase error is negative. To compensate for the turn ratio error, sometimes manufacturers adjust the number of primary or secondary turns. Nowadays, most of the VTs that are used in the industry are either inductive VTs or capacitive VTs, which are called CVT. CVTs are composed of an inductive VT, a high voltage capacitive divider, and a compensator reactor. In the IEC standard, the title CVT is used for this equipment, but in the ANSI standard, this equipment is called CCVT. The compensator reactor is designed in a way that it can compensate for the phase displacement caused by the capacitive divider. All CVTs can be used for measurement purposes, but only certain types of this equipment are suitable for protection purposes. Dual-purpose CVTs must be in accordance with all the considered descriptions and the current standards. According to the maximum allowed error percentage, the accuracy class of protection CVTs is considered to be from 5% of the nominal voltage to a coefficient of the nominal voltage, and after its value, the letter P is used. 3P and 6P are the standard accuracy classes for protection CVTs. For example, CP accuracy class means that the maximum allowed error is 3%. Moreover, in IEC standard, three classes of T1, T2, and T3 are considered for the function of CVT in transient state. For example, 3P T2 class indicates that the function of the 3P class is for protection purposes, and T2 class is for transient states. Classes related to the transient responses are defined in the following table. In the above relation, UST is the response for the transient secondary voltage. For example, for the 3PT2 class, the relation of the transient voltage to the nominal voltage peak from 10 milliseconds to 90 milliseconds after the beginning of the transient state, it should decrease and be in the range of less than 25 times to 0.2. In this regard, it is necessary to pay attention to several points. CVTs need a damping piece of equipment for the 6PT3 and 3PT3 transient response classes. By agreement between the manufacturer company and the customer, it is possible to consider different values for the turn ratio and TS time. Selecting the transient response class depends on the characteristics of the protection relays. About measuring CVTs, the accuracy class is defined based on the highest allowed error percentage in the nominal voltage with the nominal burden. The standard accuracy classes for single-phase measuring CVTs are considered to be 0.2, 0.5, 1, and 3. Test Object tab. To perform a test, every module needs a set of information about the equipment which is entered in Test Object. In this tab, the general characteristics of the CVT and its information for performing the test and adding to the report are specified. In Data section, information such as serial number, model, the manufacturer company, and the installation location of the CVT are entered to be added to the report. In Winding Material Field in Temperature Correction section, the conductor type of the winding is selected from among copper and aluminium. In Winding Temperature Field, the current temperature of the windings, and in Reference Temperature Field, the reference temperature for measuring the resistance of the windings are entered so that they can be used to correct the values measured in different temperatures. Usually, the reference temperature, which is 75 degrees, is written in front of the secondary winding resistance on the plate of the CVT. In Correction Factor field, which is uneditable, the temperature correction factor is calculated by the software in accordance with the current ambient temperature, as well as the reference temperature and the winding material. It is possible to view the relation used for calculating this factor by holding the cursor on its field. The RMS value of every parameter is calculated based on the average of several time periods. As the number of these time periods increases, it takes longer to make the calculations, but also the accuracy increases, and there will be fewer fluctuations. The number of these time periods is entered in Averaging field in Noise Suppression section. This field is the same as number of period field in Setting in Signal View window. In Date field in Extra Data section, the date of performing the test is entered in AD, and and the information after the performer of the test is entered in Tested By field. Also, the information about the supervisor is entered in Approved By field. In data table, the characteristics of every core and tab are entered in every row in accordance with the characteristics plate. The core number and the tab number are entered in core number and tab number fields respectively. The primary parameters are entered in vPrimary and primary factor fields, while the secondary characteristics are entered in vSecondary and secondary factor fields. The burden is specified in VA field, and in CLP and CLM fields, the protection core and measuring of the transformer are entered respectively. Likewise, the information related to the two other tabs of CVT that are being used is specified. Also, if the characteristics of the VT resistance are available, it is possible to check Show Resistance Column option to add the related column to the table. By checking this option, some changes are made in the DC resistance test table, which will be thoroughly explained in the related video. Also, by pressing the Add to Report option in the box at the bottom, this information is added to the output report and a message stating the report was added to the list is displayed. It is possible to view the report by selecting Report window from the bar on the right. By clicking on Delete Report option in Delete from Report window, the added report is removed. If Set as Default option is checked, the entered information is saved as default, and every time by opening the capacitive voltage transformer room, this information is displayed.